We are looking at question number 18 from CSAT 2025. This is a very good question and we will solve this question in two ways. One is using options, another one is the actual mathematical way to solve such questions. So what the input given to us is a 4-digit number n is such that when divided by 3, 5, 6, 9, n is a 4-digit number, and when divided by 3, 5, 6 and 9, 3, 5, 6 and 9, it leaves a remainder of 1, 3, 4 and 7. So this is the input is given, and what output is being asked is what is the smallest value of n is. Value of n पूछा कि n की smallest value क्या हो सकती है. So the first method, the easier one is we will solve this question using options. So how do we solve that? Divisibility rule of 5, we know that. Why 5 I am picking the first? Because 5 is the easiest one. So divisibility rule of 5 says that if unitary digit is 0 or 5, it will be completely divisible. So let's go option by option. 1068. I know that 1065 is completely divisible by 5 plus 3. So remainder will be 3, and 5 when divided by 5, the remainder should be 3. This is a possible answer. 107270 divided by 5 plus 2. So this will be completely divided. The remainder will be 2, not 3. So this option crosses out. Again 1078. So we have 1075 plus 3. 1075 divided by 5 remainder will be 0, and we will have a remainder of 3. So this option stays. And 1082. So again 1080 plus 2. This is completely divisible by 5, and 2 will be the remainder, and so this is also not possible. So we have eliminated two options by looking for the divisibility of 5. Now if I look at the divisibility from 3, so what it says is 6 plus 1 7, or 8 plus 7 is 15. So this will be completely divisible by 3, and we should have a remainder of 1 when divided by 3. So this option also crosses out, and we can reach our answer, option C. So that was the easier option. We just check each and every number, easier method, and we just check the each and every option, and we found the right answer. In exam, we can use this. But let's assume there are more answers in the exam for this, or the question is framed like that. What would be the sum of digits of n? Sum of digits of n. Let's assume instead of giving us the asking the number of n, the examiner can ask the sum of digits of n. In that case, we have to solve for n. We have to find the n. So let's assume next year the question comes, everything is same. It is asking sum of digits of n. Then how we will solve it? That is method 2. That is actual mathematical way, and that's where the applications of LCM comes in. So what we can see is n is a number, any number. Let's assume. Let's take example 12. 12 when divided by 3 leaves no remainder. 12 when divided by 5 leaves a remainder of 2. So what I can say is 12 is equals to 5 into 2 plus 2. 5 into 2 is 10 plus 2, and the remainder of 2 will come here. So what did I do? What is 12? I went to a number 10 and then went to plus 2, and that's how I can find 12. And 12 again divided by 6 leaves no remainder, and 12 divided by 9, that will be remainder 3. So what I can say is 9 into 1 plus 3. This much I can understand. Now it says is all remainders are different. So 12 is the same number. I divided by 5, remainder came 2. 12 is the same number, divided by 9, remainder came 3, and divided by 3 and 6 is left no remainder. If I divide 12 by 11, the remainder will be 1. So same number divided by different integers, the different numbers can leave different remainders. That's clear to us. But if we look at the difference between these numbers, so divided by 3, remainder is minus 1 equals to 2. Divided by 5, remainder is 3, difference is again equals to 2. Divided by 6, remainder is 4, difference is again equals to 2. Divided by 9 minus 7, difference is again equals to 2. Now how that comes into the picture? Okay, to understand this, let's assume there is a number 42 and it is being divided by 5, 9 and 15. So if I divide 42 by 5, I have a remainder of 2. If I divide 42 by 9, I will have a remainder of 6. And if I divide 42 by 15, then I will have a remainder of 12. But if I use the concept of negative remainders, how do we use the concept of negative remainders? I will not go till 40. 5 8 is 40, but I will go one step ahead in 5 table. So if I write this 42 by 5, I can write 42 is equals to 5 into 9 minus 3. The thing is same. 42 is still divided by 5 and remainder will be plus 2. 5 into 8 is 40 plus 2. But if I look at this way, if I can write 42 in another way, like divided the 42 by 5, 5 into 9 is 45 and minus 3. And if I look again for 9, 42 is equals to again 5, 9 into 5 this time. 5, this one 5 is here, and 9, and this 9 is here. 9 into 5 is 45, again minus 3. So earlier the remainder was plus 6, but now the remainder is minus 3. And if I again say 15, and if I divide 4, if I go one step ahead in like one term ahead in 15 table, 15 into 3 will again 45, and minus 3 will give me 42. So now this remainder is same. Now this we can look at the earlier slide. Like 3 minus 1 is equals to 2, 5 minus 3 is equals to 2. Every time the difference comes out to be 2. So what is happening is, let's assume 42 was that number. We don't know the number. And the question was, there is a 2-digit number which is divided by 5, 9 and 15, leaves a remainder of, let's say, 2, 6 and 12. We don't know what the number 42 is right now. And the question was, if a 2-digit number divided by 5, 9 and 15 leaves a remainder of 2, 6 and 12, what would be the smallest value of that 2-digit number? So what we have seen is, if I go one step ahead in the table of 5 and I write minus 3 from that table. So what the n can be? 5 into some k1, and I will write minus 3 here. K1 is unknown, n is unknown, 42 is unknown, k1 is unknown. And if I write minus 3, from where did I get the minus 3? 5 minus 2 is equals to 3. And I am subtracting this 3 from the total number. Why I am doing this? Because I am going one step ahead. I am not stopping at 40. I am going till 45 and I am coming back to 42. There are two ways to reach to 42. I am reading the table of 5. There are two ways I can reach to 42. 5, 5 1s are 1, and I will keep doing. 5 7s are 35, 5 8s are 40. And I can stop at 40, and I can add 2, and I will reach 42. But in this step, I am doing the reverse thing. I am going till 9. 5 9s are 45, and then I am coming back. So here is 40, here is 45. I am reading the table of 5. So first I stopped at 35, then I stopped at 40. Instead of going to 42 directly, 40 plus 2, I went to 45 and then came back, minus 3. Why I am doing this? Because this minus 3 is common for all the three numbers. I can see 9 minus 6 is 3, 15 minus 12 is 3. So there is only difference of 3 for each the divisor is the number 5, 9 and 15. The difference of 3. If I go to the next step and I come back, I have to only come back to 3 steps. So if I look at the table of 15, let's say 15 1s are 15, 15 2s are 30, 15 3s are 45. So 15 3 45, and if I come back, I have to just only come back to 3 steps. How did I figure it out? I subtracted 5 minus 2, 9 minus 6, 15 minus 12. The remainder is, the answer is 3 in all those cases, and I'm coming back to that number. So if in this case, if I can know how to come to the 45, then I know that my n would be less than 3 of 45. And if you look closely, 45 is nothing but LCM of 45 is equals to LCM of all those three numbers. What we are taking the example is 5, 9 and 15. So if इनका LCM निकालते हैं, 5, 9, 15, 5, 1, 9, I think 3 will stay, 3 1 3 1, and again 3 1 1 1. So what is the LCM? 3 into 3 into 5 is equals to 45. So 45 is the LCM of these three numbers, and if I subtract 3 from it, I can get 42. Now coming back to our question. So to solve this, the difference is 2, 3 minus 1, this minus this, difference is 2, we all know that. So what will I have to do is, I have to find the LCM of 3, 3, 5, 6, 9. So to find the LCM of 3, I will go 1, 5, 2, 3, and I don't think there is any more common factor, so I have to multiply them. 3 into 5 into 2 into 3, so it comes out to be 590. And if I say 90, or now I have to, so LCM is 2 step ahead. So here will be 19, here will be 88. Why 2 step back? 90 minus 2. Why 2 step back? Because the difference between the divisor and the remainder is only of 2. So 90 minus 2 will be 88. And if I look at, if I'm just check all the numbers. So if I divide by 88 by 3. So 88 by 3 would be 3 no, remainder is 1. If I divide 88 by 5, remainder will be 3. If I divide 88 by 6 per se, then the remainder will be 6 come 6, 2, 8. Remainder would be 4. If I divide 88 by 9, the remainder would be 7. But question is not asking us a 2-digit number. Question is asking us a 4-digit number. So whatever the number would be on the multiples of this LCM. So I will keep multiplying 90. Let's say I have to reach to the smallest to the 4 digit. So 19 into 10 would give me 900. 19 into 11 would be giving me 19 into 11 would be 990. And if I do 90 into 12, I reach 1080. And if I do minus 2, then I will reach 1078. That's the answer. If it would have asked the smallest 3-digit number, then I would 90 into 2, that would be 180 minus 2, 178 would have been the answer. So to sum it up, we are using a concept of LCM, and on top of that we are using the concept of negative remainders. What we have seen is, we have seen a small example. Let's assume number was 42, which is known to us for the time being, and we have to divide it by 5, 9 and 15. We can write 42 in two ways. 42 is 5 into 8 plus 2, or 42 is 5 into 9 minus 3. Why I am going ahead and writing it? I am going ahead and writing it like this because this minus 3 part is, the difference is same for all the numbers. 5, 9 and 15 all leaves a different remainder, 2, 6 and 12. But if I see the difference between this number, the divisor and the remainder, this is same for every number. 9 minus 6, 15 minus 12, 3. That's why I'm going one step ahead on the table of 5, then the table of 9, then the table of 15, and then coming back by dividing it minus 3. So what I figured out was, if I can find the 45 somehow, if I can find the 45 somehow, if I can find that, then I can know the n also, the 42. I know in this example, but I don't know in the exam. So how to get 42? 45 minus 3. I can get 42. That's the answer n. But how to find 45? 45, that is the LCM of these three numbers, or a multiple of these three numbers of LCM of these three numbers. So we figured out the LCM. 45 आया, minus 3 किया, 42 आ गया. The same thing we can do in our question. 3, 5, 6, 9. इन सबका मैंने LCM निकाला. इन सबका LCM आया 90. And as it is question asking the smallest 4-digit number, smallest value and 4 digit होना चाहिए. So it should be 9, something in 90 का multiple minus 2. So 90 into 12 किया तो 1080 minus 2, 1078 आ गया answer. The concept is complicated for sure. If you have any questions, you can leave a comment. Otherwise, do like, share and subscribe. Thank you for watching.